Practice exam paper, page 1. So for question 1, we've got hikers walking northwesterly direction for 8 kilometres. So we'll put, here's our north. Northwesterly will be here at 45 degrees. 45 degrees, and they've travelled for 8 kilometres. There. So now they change direction and they walk due south. So this is our, here we can put our north in so we can see where our south is. We'll be due south here. And we're going to be going until there's a bearing of south 40 degrees west from the starting point. So we're looking at our starting point here. There's our south, there's our west. We've got south 40 degrees west. Here's our 40 degrees. And we're travelling from here, we're travelling due south. So here we're travelling this way. And we want to find how far are they from where they started. So we want to find this length here, x. So our first thing that we need to do is work out our angles within our triangle. So we look here, we've got our parallel lines for our two norths. So here we have alternate angles. This angle here will be 45 degrees. Same here from our original north, we've got 40 degrees here. Using our alternate angles or our Z angles, this one will be 40 degrees. So now we can start to think about our sine rule. So our sine rule, we have our x divided by our, well, here we can put our labels on. We'll have, here we can have our A on our sine A. We know this length here of 8 kilometres. The x we want, that will be our B on sine of B, the opposite angle here. So we know, well, here we have A on sine of A is B on sine of B. So here 8 divided by sine 40 is equal to our x divided by sine 45. Rearranging for x is equal to 8 sine 45 divided by sine of 40 degrees into the calculator, and we should get, here we want correct to one decimal place, so 8.8 kilometres. So now looking at part B, we're considering this diagram below. We have two yachts, A and B. There's our A and our B. Subtend an angle of 80 degrees at the base C of a cliff. So we're saying this angle here is 80 degrees. From yacht A, the angle of elevation, so up, of the point P, which is 100 metres vertically above C. So we know that this is 100 metres. And we know that this yacht here, the angle here is 20 degrees for yacht A. For yacht B, the angle of elevation here to our point P is 15 degrees. So for part 1, we're just adding those 4 pieces of information to the diagram. For part B, we want to find out, well, how far apart are these two yachts? So what is this distance from A to B here? So we look at what we know here. We know this length here, and we can relate it to this length here. So we know, okay, well, we know here we're going to get two lengths. We can use our cosine rule. And to find this length here, we can find it in terms, here we know, well, tan of 20 degrees is our opposite, 100 metres divided by, and we'll call this A and this can be B. So divided by A. So we rearrange. A is equal to 100 on tan of 20 degrees, or we could write it as 100 cot 20 degrees. Exactly the same for our length B here. Tan 15 degrees is our opposite, 100 over our B. Rearrange. B is 100 on tan of 15 degrees, or 100 cot 15 degrees. So now we can use our cosine rule. So our cosine rule, we have A squared is B squared plus C squared minus 2BC cosine of A. So here what we're going to do, we'll relabel. It doesn't matter at this point, but we'll relabel. This one here will be our A, and our point A here at C. We know that they're opposite, so that's our capital A. That's our angle that we know, and that's what we want to find. So perfect there. And then here our B can stay as a B, and this can become our C. So substituting in, our A squared is X squared is equal to B squared here. So here it's going to be 100 squared cot squared 15 degrees plus our C squared is this A here, 100 squared cot squared 20 degrees minus 2 times B times C, 2 times 100 times cot 20 degrees times 100 cot 15 degrees multiplied by our cosine of A, which is 80 degrees. Our X will be the square root of all of this, and if we put this into our calculator, we're going to get 423, correct to 3 significant figures there. Okay, so moving further down to question 2. So here, our first step we're going to do, we'll get rid of our easiest thing we can here. We've got 2 ways we can go about it, but first we'll get rid of this. 24 is 2 times 12, so 2 and 1. So then we've got A squared, B negative 4. Here we've got 2A, the power of negative 3, B. So our 2 ways we can do this. We can say, well, here we've got, here A at the top and minus 3 at the bottom. So A squared and our minus 3, and we minus that minus 3. So we're going to end up plussing that 3. And then we've got B to the power of negative 4, and then here we've got B to the power of 1 at the bottom, so negative 1. So we've gotten rid of our A's and our B's on 2. So it's going to be A to the power of 5, B to the power of negative 5 on 2, or A to the power of 5 on 2, B to the power of 5. Our other way is to just put them all into a line here. So if we work it out, we've got a half out the front, then we've got A squared, B to the power of negative 4, then multiplied by here, at the bottom we've got A negative 3. So that when it changes up becomes positive 3. And B to the power of 1, when we move it up, becomes negative 1. And we go through the same process. We have a half. A, we've got 2 and 3, makes 5. And B, we've got negative 4 and negative 1. And we end up exactly the same, A to the power of 5 on 2B to the power of 5 there. Moving down to question 3. We want to solve this for x. So we want to find what x is. And it's going to be a bit of a long process. We've got a bit to do here. So first of all, we'll get rid of this 3 in our denominator here. We'll get all our units here. We're going to multiply by 3, multiply by 3, multiply by 3. So we've multiplied everything here by 3. This will cancel out, so we get x plus 3. Then we've got here, we've got 2 times 3 is 6. X minus 4 times 3 is 12. On 7 equals 2 times 3 is 6. So now we're doing pretty well. We need to get rid of this 7 on the denominator. So we're going to multiply by 7, and we'll multiply this term here also by 7. So we've multiplied everything by 7. These cancel out. 7 times x is 7x. 7 times 3 is 21. Here we've got 6x minus 12. Notice that I've left it in the bracket because we have 2 negatives. We don't want to get confused. And 6 times 7 is 42. So now we've got 7x plus 21 minus 6x minus becomes plus 12 is 42. 7x minus 6x gives us x. 42 minus 21 minus 12 will give us 9. And for our last question, on page 1, we want to find the value of x here. And what we can do, we know this angle here, we know this length here, and as x, we'll make this y. What we can do is relate these to this common length here, which we're going to call y. If we look at this first triangle here with the 50 degrees, y is our opposite and 5 is our adjacent. So here we're going to have, well, tan of 50 degrees is y divided by 5. We can rearrange. Y is therefore equal to 5 times tan of 50 degrees. So we know this now. We can say, well, we know that this is 5 times tan of 50. We could put it in our calculator, but we're not going to simplify it down to our units yet. Now we're going to look at our second larger triangle. So we're looking here with our 40 degrees here and using the same tan equation. So tan of 40 degrees is equal to this y, which is our opposite, divided by here, this total length is x plus 5. So we can rearrange here. So x plus 5 is equal to y on tan of 40 degrees. We can substitute here. We know y is equal to 5 times tan of 50 degrees. We're dividing by tan of 40 degrees. And this is our x plus 5, so we can find, well, our length x will be 5 times tan of 50 degrees divided by tan of 40 degrees minus 5. So if we put this into our calculator, we're going to get 2.10 units. So we haven't mentioned what this length 5 is. We don't know what it is, so we just write units in there.